Hey everyone, it's great to have you all here on the Monthly Dev. This is our fourth event so far since we launched on last January. If you don't know the Monthly Dev yet, it's a series of monthly online events where we bring world-class speakers to teach and inspire us all. We organize these events to create a TED-like platform for us, for developers. I am Ido from daily.dev, and I'll be your host for this morning, evening, or wherever you are, and whatever time it is in your place. Let's see who is going to speak for us today. So first, we will start with Matteo, who will give us a short introduction to its revolutionary framework, Fastify. Followed by Ella, who will teach us what is GraphQL and when we should consider it for our applications. And lastly, we have Eldad, the founder of Appwrite, who will explain how to keep everything simple and avoid complexity in our team and our organization. If by some miracle you don't know about daily.dev yet, it's a community and a platform that gathers all the programming news in one place. Do try it out after the event. We have an extension and a progressive web application with mobile support, so try it out. If you want to get some swag of daily.dev branded swag, today we are giving out a backpack for you to enjoy and put whatever you want and take it wherever you want. Just all you have to do is just share the event and add the monthly dev hashtag, and we will pick the 10 most creative shares. And as I mentioned, the winner will get a branded backpack for free. So make sure to keep your DMs open so we can contact you. And yes, we would love to see your faces on social media, so make sure to add your selfie or whatever you want. And lastly, just quickly before we start this event, 2 weeks ago, we started a monthly raffle for you to win epic prizes. And today we are going to announce the first winner who will get the brand new Apple Watch. So stay tuned, we are going to do the announcement just after the event. And we are going also to announce the next prize. So if you didn't have the chance to take part in this raffle, you will be able to join in the next one. So are you ready for the first speaker for today? The next speaker is part of the technical committee of Node.js and the maintainer of one of my personal favorite open source packages. Please welcome Matteo on stage.
Hi everyone! If I didn't, I forgot to turn on the mic as usual. So yay! Here we go. Hi everyone! I'm very happy to be here at the monthly dev, and hope you enjoyed all these. Enjoy this talk. It's and my work of the last maybe four, maybe even 5 years at this point, close to 5 years. So that's how much I've been working on Fastify. So let me know if you have any questions anyway.
Yeah. So Matteo, I see you are all set up to the talk.
Yes.
I just want to tell to the audience to show their love in the comments and show their support to you. And yeah, take it from here and good luck.
Thank you. Thank you. So, hi folks. Oh, here are the slides. Okay, you can see the slides over here. Okay, nice, cool. So, welcome everybody. I am Matteo Collina at Matteo Collina on Twitter. Please take some time, open Twitter, follow me. If you have any questions that if I can't respond to them during my talk, you can always send them on Twitter. My DMs are open. So if you have some questions, please ask them there. A little bit of note of NearForm. It's the company I work for. I'm technical director there. I manage teams. I also write a lot of open source, do conference talks, do a lot of other stuff. In case you wonder, we are hiring. So if you want to change of scenery, whatever, happy to give to chat. We are a professional services company in the JavaScript world. Anyway, let's get started and jump in. This talk, it's about Fastify. So hey, this nice cat, Fastify.io. I'm not really a cat person, but we ended up having a big cat as our mascot for Fastify. Anyway, let's talk a little bit about Fastify and what Fastify is. Fastify has started with a clear assessment that an open source project is as good as its community is. This is one of the key part of the Fastify ethos, and it's not about technology. It's not, it's about people. And one of my key ideas is that Fastify, in order for Fastify to be successful, it should have a strong community behind it. We are going to tackle a very hard market. There was already a clear winner with millions of downloads per month. And how could we grow? How could we build something that could, become legacy and become the next big framework? And what we started was, we need to solve the community problem. So we really focused on onboarding as many new contributors as we could. We added them early on, and if you contribute a lot to Fastify, you will get the commitment. Fastify is one of the fastest web framework for Node.js. There are probably faster ones that do very little. So, but it has probably one of the best comparison of features versus speed. It's also been downloaded roughly 900,000 times per month. But we're close to 1 million, we'll get to 1 million soon. It has 15 collaborators, committers, whatever you want to call it. It has version 3. We are working on version 4, by the way, so we're going to do some breaking changes in the next few months. And it has an ecosystem of 188 plugins that you can download and use right now. It offers a very simple interface, so you can see a very quick demo here. You can just do app.get and you pass your handler, and you can if you just return an object, it just works. So this is rendered as JSON. One of the features, it has an embedded logger, as you can see it here. We'll see all the other changes in a second. As I said, the core values of Fastify is that it has an open governance and with consensus seeking. Essentially, we tend to ask for objections. We ask, does anybody object? We ask if people are okay with the changes. They can approve or deny or say, well, I just, I don't care. So but we tend to not disappoint anybody. So if you are a collaborator, if you are a contributor, you can actually get, you will be part of this consensus seeking program. We are community first, as I said. By the way, this open governance bit, we took it from Node.core and the level community, so long time ago. So all the success that has been driven in those communities is part of Fastify. It's community first, so we welcome first-time contributors. We want you to succeed. In fact, our key part of Fastify is the concept of shared ownership. Mostly, it's one of the key problems in open source sustainability is providing support and providing help in helping others. So Fastify it's everybody's framework. We ask people if there is a bug to, would you like to send a pull request? Would you like to fix this problem for yourself? It's more or less, we can't fix everybody's bug. And this is one of the hardest bit possible because we can't, given that we can't help anybody, we are not a company, we are not funded, we have no real, we are users of this framework, okay? We built this framework to be used. So because we are users, you can actually add, we contribute back, you should too. So that's the key part of Fastify. So just all of this to say that Fastify is a web framework, but in fact, it was born as a community. And it was born as a community before any code was actually committed. So I started toying with the idea of writing a new web framework for Node back in 2016. And I said, well, this is such a hard problem that I will not be able to do it alone. I need to convince another human being to write this with me. At the time, I delivered a talk. I was delivering a Node.js training course in Bologna, Italy. I live in Italy, by the way. Hi, Bologna. hello, I love you. And I was in Italy, and I delivered this training course, and one of the attendees asked me, "Oh, well, you're having such a great success in open source. How do I get started in open source?" Well, I don't know, but I'm starting to write in this new thing. I would really want to have somebody else to help me on it. Are you up for it or not? And I met this young, talented developer called Thomas della Vedova, and we started working together on what it has been Fastify. And Thomas now is a senior software engineer at Elastic, so he's been doing pretty great. And I don't know, Fastify is born out of nowhere, and we started working on it. We kept working on it. Took maybe a couple of years to get 1.0, and then we got 2.0, and then 3.0, and now we're doing 4.0 pretty soon. So doing great. Again, one of the key problems in the other framework for Node.js is that maintaining one of those, it's a huge amount of effort, and it's really hard to justify it without having funding or a company behind. So what we have chosen is to spread this effort along everybody that is using this framework. So that's it. So if you essentially, this is the key part of the Fastify culture. Please, if you find a bug, fix it yourself, more or less. We are happy to guide you along the way, but definitely go and help yourself. This is the governance bit, and we nominate contributors, collaborators all the time. So people that have contributed significantly, we nominate them. Let's go about and talk a little bit about the technical principles of the framework. So one of the first one, I'm keen on this, is as close to zero overhead in production. You can't really get to zero because it's JavaScript and it's Node, but you don't want to increase. You want to reduce the gap between Node Core and Fastify and Fastify as much as you can, while providing a good developer experience. Which means that you need to be able to use this nicely in development, essentially, and have a good experience with it. I can write some really fast code that does not, probably even faster, that does not have a good developer experience. So you might really want to do that. This is really important. I wanted it to work great for small and big projects. So I wanted to scale, to take your company from your project from one engineer to 100, and to scale and support all of the use case of these different kind of complexities. One of the problems that I've seen in other frameworks is that they will become really hard to work with once they reach a certain size. And that is something that I did not want I did want to fix with Fastify. Because in fact, we want to support an easy to migrate path from to microservices and back. So Fastify, you can deploy Fastify as a monolith. You can deploy Fastify as different microservices. You can use them, deploy them in a serverless fashion. You can use it more or less in a lot of different ways. So yay, great. I wanted to have some good security out of the box with embedded data validation. So whenever you have a post, we support automatic data validation, because before the data even enters your code. So in this way, you're sure that your data is actually secure. We make great steps to make it so. There is, for example, is automatic protection against port-side pollution attacks. So it's good. It has a plugin system, so if something could be a plugin, it likely should. It's easily testable. We do not monkey patch Node Core. This is something that was done by Express and Restify and possibly others. We don't do that. Okay, we just wrap it, and it has a good long-term support, and we want it to be to follow the spec as much as we can. So how fast is Fastify? Well, Fastify is damn fast. There are probably other alternatives that might be slightly faster, whatever. There is a reason why we are slightly faster than Node Core, and I'll show you why. This is Fastify supports. By the way, this is a test for rendering a simple JSON document. Most of what we do as developers these days is writing APIs that return JSONs. So we felt this was a very good use case. and poor express. Sorry. It's also loved by devs. So Fastify developers that has been using Fastify have been loving it. I'm pretty happy to be into this chain and be part of the state of JS. As much as this survey counts, there's not a lot of people that participated, but pretty great. In case you wondered, there is also I've also written a library to do GraphQL. And this library is actually pretty great from my point of view. It's fast. You should check it out. It's called Mercurius. You can find it at mercurius.dev. It's pretty good. So it supports a lot of things, all the things that you would expect to be they're there. So as I said, there is a concept of plugins. So there is a thing called core plugins. And core plugins are maintained by us, by the Fastify org. And we guarantee them to work on every new major. So we release a new major, we also bump a major in all the plugins, essentially. They also tend to solve the problem in the most idiomatic way. So, however, there are also ecosystem plugins that are, plugins that are maintained by the members of the community, including me, by the way. I can maintain some plugins that are ecosystem plugins, but not that are not, part of the org for whatever reason, and they want them to. So, and we have about 140 community plugins. So that's kind of good. The target architecture for Fastify, it's a typical model view controller. So, well, wait a second. One of the target architectures is I made a mess. So in the past, what you had was you had a typical architecture was having Express as the web framework, having your controllers, your routes, whatever, and having your model either as using Mongoose or SQLize or something. There was no view whatsoever. Okay, so this was the typical mean or MERN stack. However, this does not scale well. The problem why this does not scale well, it's because, in complexity, I said I wanted the framework to work for small projects or big projects alike. So when we add, it doesn't scale in complexity because you only have 3 boxes even, but even 2 boxes to put your logic in. It was either a controller or a model. That was not really good because I've seen projects with 2,000, 3,000 models in them. It was really hard to work with. So this does not scale well in complexity. So I would not recommend you to go down this target architecture. However, there's a slightly similar architecture that you can go with. By the way, this architecture has the clear benefit of having one single deployment unit and that you can just replicate ad libitum. So a lot of companies and projects at the beginning use this target architecture because it's very easy to deploy. Well, the architecture that I recommend most projects to start is to use a horizontal architecture. So instead of dividing your code in models and controllers, I would recommend them just to write simple JavaScript files that each of them are mostly self-contained. The beauty of this is that these can scale horizontally very easily, because we can actually support it because each then is mostly independent. They might have some shared logic somewhere else, but they're independent as much as possible. These allow us to have the same level of horizontal scalability because we have a single node process, but also we can have different teams working on different areas of the application without overstepping on each other's feet. So pretty good. However, this code is actually very similar to what a microservice network is, a microservice mesh is. So you can easily migrate from one to the other and vice versa very quickly. So I really like that type of architecture. I want to go a little bit in depth on the framework. So the framework is based on Find My Way, And so these are the key components, some of the base libraries. We have Find My Way, which is the router, AJV, which is our validator. Fast JSON Stringify is part of the magic. We'll show it later. We have Avio, which is the plugin system and the bootloader, and Pino, which is our logger. And these are like what Fastify provides internal. We have plugin system, hooks, and decorators. All of these, is part of the extensibility bit. It's pretty good. The plugin system for Fastify is built on the concept that we want things to be encapsulated. So when you publish something in a plugin, you doesn't get the other plugin can't see it. So just to explain, if you publish something on plugin 1, like for example a hook or a decorator, it won't get the entry point, and plugin 2 will not see it. So it's a decorator. What a decorator is? Well, decorator is used to publish, to add something to the request object or the reply object, or for example, the server itself. So you want to add some property in there. So essentially, you only the shenanigans can see it. So if the plugin 2 calls the decorator, only plugin 3 will see it. You can actually break the encapsulation by using a little utility called Fastify plugin, so that we'll publish it on the parent, so that the other siblings will see it as well. It's pretty good. We support the concept of request lifecycles. So we don't have, so there is some level of middleware support in Fastify, but we recommend to use the lifecycles. The lifecycle is great because when you receive a request, you can put some logic, execute custom logic in any single of these steps. We have on request, when it happens, we have the pre-parsing before, like the parsing of the content type and the body. We have like a pre-validation hook to validate before that is executed, before validated. By the way, this is still some stuff. This is unvalidated data, so it might be something that you want to do before that. And then we have a pre-handler before the actual user handler. And then we do a bunch of other bits. So, sorry about this. What structure we recommend? Well, we recommend having an app.js, plugins folder, routes, and some tests. So, and with the plugins in the plugins folder, use Fastify plugin to actually like decorate things so that their stuff it's shared. Plugins is for the shared component. The great things is that a Fastify app can then be structured, can easily map to our target architecture. So we can have like our different modules here that are mapped into subtrees of routes, or sub apps, so that you can actually deploy the thing as a single unit, but have actually 3 independent blocks with their own dependencies even, so that can be completely autonomous. In Fastify is so flexible that you can even embed a full Express application in it, and it will all magically works. As I said, Fastify has embedded support for Pino, which is probably the fastest logger for Node.js. But again, we do new version. How do you use Pino? Well, you do the required and so on. Well, I was mentioning that Fastify was fast because there were some tricks. This is one of the tricks. So Fastify allows to, like, if you can specify a schema for your response. So it helps you specifying what the format will be. And then it uses this library called Fast JSON Stringify to use that schema to generate a customized function that is really fast at generating that data. It's also slightly safer to use this than just using JSON Stringify, because it can avoid like unneeded properties and so on and so forth. This is great. And it can allow us to actually be slightly faster than Node Core because of the custom JSON Stringify. There is also this other library called Fluent JSON Schema that you can actually use it to simplify how you write things. And by the way, remember that AJV is one of the fastest validators. So I really like AJV. One of the other bits that Fastify includes is the inject method. So if you define this, a function like this, you can always, in any piece of the code, just do await app.inject, and that will actually call our app. And by the way, I recommend this structure where there is a build step and a test, and test that call the build step. Note that we don't use any globals, so you can actually spin up as many Fastify applications you want within the same app. It also supports Lambda, as I said, so you can actually take it. There's a module to support Lambda, easy, and you can just do that. And you can use the same code to, you can write the same, your Fastify application as normal, but use this AWS Lambda module to actually do your thing. It has some graceful shutdown system, but we're probably a little bit late, so I'm not going to spend some time on it. So before I finish, I wanted to show you a demo. As I said, I work for NearForm, so if you have any questions, at Matteo Collina on Twitter. And we are also hiring. If you want to work on Fastify, that's actually a very good place to start with. So here we go. So this is my a little bit of live coding. So I hope the demo gods will be with me. We have nothing here. So what I can do is I can start with a thing called server.js, and I'm going to use the new ES6 syntax. So I can do import Fastify from Fastify. Hey. And then I can do post app. I can call Fastify. I'm going to pass in an object, and I'm turning on the logger. Here we go. And then I can do await app.listen 3000. Note that I can do, I'm using top level await here. So what I can do, if I'm using Node 4, for example, I can do node server. And as you see, this is working. And local host 3000. Okay, not found. Cool. Note that I can even, if I like my logs a little bit better, I can actually use Pinopretty to run my code. So, hey, yeah, makes sense. Cool. So how we move for it? Well, we can define a route. So we can do. We can do app.get, and as I said, we can do this sync. Word. Here we go. Okay. So what we do now, we do node server, and then okay, and then I do yay, I did it wrong. Be something like this. Oh, wait, it was correct. I can't do this probably, so I need to do it. Let's do it properly. Here we go. Okay, now it's working as expected. Cool. Okay. So this is my this is a very basic way to start your Fastify server. Now, I typically recommend to split this into, well, let's copy these bits, and I am opening up a file app.js. So I'm doing something like this. So what I'm doing is I'm doing export default sync function build oops. And here we go. So I'm doing this, and then I'm doing return app. What I'm doing in server is that I am going, instead of doing things, I'm doing import build from app.js. So instead of doing this, I am doing await build, and then I am doing await app listen. Let's see if I refactored this correctly. Cool, it's still working. I wanted just to show you one last feature before I finish. I probably can keep going with this for like half an hour. I think it would be a good chat, but probably not what you're looking for. So there is a roots folder. that I have pre-prepared. So in this root folder, you see that we have our route here. What I can do instead of loading it in this way, what I can do is I can import autoload from autoload. I also need another tiny utility, so which is called DSM, because I need to convert to some joins, and I wrote this utility, so I know how to use this thing. I need just to do register autoload. This is our register plugin, and then I need to pass in an option, and I need to tell this plugin to automatically load all the plugin in the routes folder. So what I'm doing is I'm doing calling join, which import URL, which is the path of the current file, and then I am putting down their routes, and hopefully these would still work. So import, meta, and it's still working. Cool. Okay, so if you go into hello, you can say that, let's say hello dev. And if we do this, you will see that it's just changed. So perfect. I think that's all. And yay! Thank you for watching.
Thank you, Matteo. Actually, we got a few questions from the audience.
Cool.
So let's go over it real quick because we are behind schedule a little bit.
Sorry, my fault. I went over.
Yeah, no worries about it. So first question, what's the difference between Fastify and Next.js or Sales.js?
Okay, Fastify does not ship an ORM. So it's so that's the main difference from Sales.js. Mm-hmm. Next, it's a React server-side framework. So Fastify is mainly built as an API server, and it has all the features you need to build great HTTP APIs, great GraphQL support, all the things that you need from a server-side point of view. Next.js is mostly a React, a React thing.
Okay, perfect. Thank you. Next question is what I need to do to become a contributor.
This is actually a very great question. This is a question that I love. So you just need to go into fastify.io, and there is a tab there called contribute. So at the top, you see contribute as a tab there, and it's essentially it provides you a list of good first contributions. So there's plenty of tasks that you can take in Fastify that you can actually help quickly to help you quickly get started, essentially. So you will start contributing, and then after a while, you will get the commit bit, and the name on the README is if you have been doing this for a bit of time.
Perfect. Another question: can a schema be multiple schemas actually?
So there is full support for any of one of those kind of constructor on JSON schema. So it's one schema, but you can have like some conditionals in it if you want them.
Okay. And last question for today. Does it suitable for large organization in terms of stability and security?
Absolutely. So there are there are a lot of organizations that are using this in production. For example, it's I don't know if you're familiar with a company called Net-a-Porter. And Net-a-Porter did a few blogs about that, how they're using this in production. Then there are a few others that I cannot talk about. So, but I have, if you have been living in Ireland, New York, Pennsylvania, a few other states, they probably have heard about the contact tracer app. and there was Fastify was part of that effort. We did this. Fastify was used by the COVID Green Initiative, which is the open source the open source version of that of that tracker. That was used in all these cities and was originally built by NearForm.
Wow, that's impressive. And also, daily.dev uses Fastify in production. So yeah. So Matteo, I would like to thank you very much for dedicating the time for talking here and all the time you dedicate for the open source community. And keep up with everything you do.
Thank you very much.
My suggestion is, thank you.
Go ahead.
My suggestion is if you can share the contribution link in the YouTube comments.
Yes, I just need to paste in the comments here.
Yeah.
Or just on the link?
No, you should go on YouTube.
If you can sorry. Hey, send me an email. If you send me an email, I will be happy to do it. Okay. Otherwise, I'm very bad at this stuff. Thank you. Bye.
Thank you very much. Bye-bye.
Bye-bye.
Have you heard about GraphQL recently? Because basically it's all the rage lately. It's everyone is talking about. And the next speaker would like to address specifically GraphQL and to teach you when you should use GraphQL and when you should consider it. So let's have a round of applause in the comments for Ella, who will explain all about GraphQL.
Hi.
Hey, Ella.
Hi.
How are you?
Good. I'm really excited to be here.
Yeah, we are so excited to host you here as well. And yeah, are you ready to jump in for your talk?
Yeah.
Okay, so go ahead. Good luck.
Thank you. So this talk is about GraphQL and its advantages and disadvantages compared to REST API. First, hi, nice to meet you. I'm Ella Sharakanski. I'm a software developer at a startup called Salto in Tel Aviv. And I use GraphQL every day, both in the backend and in the frontend. And there is my dog, Kinder. So Fastify has a cat and I have a dog. Anyway, enough about me. Let's talk about you. If you're Mark Zuckerberg in 2003, so you are developing Facebook, and specifically the most important part of Facebook, which is of course the feed. And you have your backend and the frontend, and you also have an API. And let's say you're using REST API. Recall that REST API is an architectural style for web APIs where we usually use HTTP methods to either get or create, update, or delete various resources. So how would you design the API for the feed? You'll probably have a /posts endpoint that returns a list of posts where each post has text and creation date and many other details. And this works just fine. And after some time, you decide that you want to increase engagement, and you have an idea: to add comments to the feed, because you believe that if people will see comments, then they'll want to comment even more. So you want to show the top 2 comments of each post right there on the feed. How will you change the API now? Well, you'll probably just add a comments field to the /posts endpoint. And this works just fine. And after some time, you decide to hire a product manager. And she takes a look at the site and has this wonderful idea: remove comments, because the feed is too cluttered and it should be nice and clean. So what would you do now? Well, you can just not show comments on the feed, but if your backend is still returning comments and calculating the top 2 comments of each post, then it's pretty wasteful. So you want to not return comments from the backend. But this is a breaking change in your API, and it also requires some work in the backend, so it's not that easy. Anyway, you decide to do this change, and maybe you are even creating a new API version just for this. And when you're done, your product manager comes with yet another great idea. And this time, it's really groundbreaking. Add comments, but only for the website, because the app should still be clean. So what would you do now? And note that this is not an easy question, because there are many possible solutions, but they all have disadvantages. And let's go over some of them. So solution number 1, the /posts endpoint won't return comments. And then in the website, you will have to ask for the comments of each post separately. This is called underfetching because the /posts endpoint doesn't return all of the data that you need. And having to send these many requests, in fact, one request for each post, is both slow and inconvenient. So let's take a look at solution number 2. The /posts endpoint will return comments, and then in the app, you just won't use them. This is called overfetching because you're fetching more data than you need. And it wastes time because your backend has to calculate the top 2 comments of each post, and then you're just not using them. And it also wastes bandwidth because you are sending these comments to the client who doesn't need them. It can even waste your client money because some clients pay for the bandwidth. So let's take a look at solution number 3. You can have a parameter view, and in the detailed view, you will return comments and you will use it in the website. And in the standard view, you won't return comments and you'll use it in the app. The thing is, there are many possibilities. Maybe you want to show the top likers of a post, and maybe you don't. Maybe you care about the author, and maybe you don't. So you'll end up having many views, like simple and simpler and full. And each view will be coupled with your frontend at that specific point in time. So for example, if you show the top likers of a post in the website, so the detailed view returns top likers, but you don't show top likers in the app, so the standard view doesn't return top likers. And then you decide that you do want to show top likers in the app, then you'll have to change your backend so that the standard view will return top likers, even though your detailed view already returns top likers. So every change in the frontend will be coupled with a change in the backend. And in the end, you'll have so many views, you won't even remember which views you have and which values each view returns. So this is both confusing and not scalable. And the thing is, you can count on your product manager to keep having these great ideas, like to show the top likers of each comment, or to support Smart TV, which is a completely different view, or to support external API consumers, meaning people that are using your API for needs you don't anticipate in advance. That's why your backend has to be convenient for many use cases. So let me introduce to you GraphQL. GraphQL stands for Graph Query Language. And I'll first explain some main concepts in GraphQL, and then I'll explain how GraphQL solves all of the problems that we've just discussed. The first main concept in GraphQL is the schema. The schema is basically a description of your API, and every GraphQL API must have a schema. Now in our case, this is what the schema might look like. So first we have the top-level type query, and then we have our top-level queries, posts, which returns a list of posts, and single post, which receives an ID and returns a post with its ID. Exclamation mark stands for not nullable. Now, the type post has ID, text, and a list of comments, and the comment type has ID and text. Having a schema has many benefits. First, it serves as a type system. So GraphQL can automatically generate types in your own language from the schema. For example, it can generate the post and the comment type and many others in C#, Java, TypeScript, and many modern languages. The second benefit of having a schema is that it serves as a contract between the client and the server. So when you're about to develop a new feature, the front-end developer and the back-end developer can first decide on the schema together, and then they can start developing the feature simultaneously because they already know what the API is going to look like. The third benefit of having a schema is that it allows introspection, meaning that when I'm about to use a new GraphQL API that I don't know, I can simply read the schema, and that will give me all of the information that I need about which queries I can make and which return values I'm going to get. In fact, how do you query a schema? Simple. You send a post request to /GraphQL. So there is only one endpoint, /GraphQL, and you can get everything you need from that endpoint. Now, in the body of the request, you have the specific query that you're after. In this case, we want the posts, and then the text and the comments of each post, and the text of each comment. The result of a query looks exactly like it. So in this case, we first have a field data, and then we have posts, which is a list of posts. Each post has text and comments, which is a list of comments, and each comment has text. Now, if you don't want to show comments anymore, then you can simply not ask for them, and then the backend won't return them and won't even calculate them. This depends on the backend implementation, but it's very easy to implement this way. So the backend will only calculate comments when you explicitly ask for them. So as you can see, GraphQL solves many of the problems that we have discussed. It helps you avoid breaking your API, because if you don't want to show comments anymore, then you can simply not ask for them, and then the backend won't even calculate them. So there's no need to change the API at all. The schema remains the same. In addition, GraphQL solves overfetching and underfetching, because you get exactly what you ask for. No wonder so many companies are using GraphQL, like PayPal, Twitter, Airbnb, GitHub, and of course, Facebook, who invented GraphQL. But how does it work? How come GraphQL only calculates comments when you explicitly ask for them? How is it implemented? Is this magic? Well, no. It's resolvers. And let me show you the TypeScript implementation of the resolvers for our case. So basically, the resolvers are an implementation of a schema. And first, we need to define this object, which describes our resolvers. So we have the top-level resolvers, post and posts, and we also have the comments resolver for the post type. Note that we don't have a resolver for the text of a post, because in this implementation, we are always calculating the text of a post when you ask for a post. But we're only calculating comments when you explicitly ask for them, and that's why we have a resolver for the comments. Now, what is a resolver? A resolver is just a function, and let me show you some examples. So first, the posts resolver. It doesn't need any arguments, and it returns a list of posts simply by calling another function, allPosts, that is probably querying our database, and then it just returns a list of posts. And note that we're only asking for the ID and the text fields of each post, because we're not calculating comments just yet. That's why we have the comments resolver. So this resolver receives one argument, which is the post that these comments belong to. And in general, every resolver can receive its parent as an argument. So the parent of comments is a post. And then we're just using the ID of the post to return the top comments. Last, the single post resolver. So it's very similar, except now we also have arguments that the client provides for us, because the client gives us the ID of the post that he's looking for. So we have args of type query post args. And this type is also auto-generated by GraphQL. And then we're just using args.id to ask for the post with this ID. And again, we're only returning the ID and the text fields of the post. Nice. So by this time, we've only learned 4 concepts in GraphQL: schema, query, result, and resolver. And you can already see how powerful and flexible GraphQL is. It's so flexible, you can get exactly what you ask for. So let's learn two more concepts in GraphQL that also show the flexibility of GraphQL: mutation and error. So first, mutation. Mutations are very similar to queries, except they're meant for doing side effects, like creating new data in your database. So it's like in REST, we have get and post methods. Then in GraphQL, we have queries and mutations. So to define a mutation, it's very similar to queries. We just need to define it in the schema. So we have the top-level type mutation, and then we have our mutation create post that receives text and returns the created post. To use a mutation, all you need to do, just as before, is send a post request to /GraphQL. And in the body, we have this time the keyword mutation, and then create post. In this case, the text is the monthly dev, and then we are asking for the text back. So note that the client can actually choose which field to ask for in return. So we can ask for the ID, the text, the author, and anything we'd like. So again, it's very, very flexible. The result of a mutation looks exactly like it. So we have data, create post, and text. Next, errors. So let's say a client asks for a post with ID 1234. And let's say there is no such post. So we want to return an error. What does it look like? It looks like this. So we have a field errors, and note the plural errors because you can actually have multiple errors. For each field, we can have errors. And then each error has a message, and also we have the path, which is about the field that has the problem. So in this case, we failed to get the post. Then we also have an optional field, extensions, and you can have anything you'd like inside of the extensions. And then, and that is important, we have data. So in this case, the data is null, but you could actually get both errors and data in one response. So for example, if a client asks for the post and then the text and the comments of a post, and let's say we failed to get the comments, but we could get the text successfully. So we'll get an error for the path of post comments because we failed to get comments, but we'll also get the data of post text. So there can be partial errors. And this is another example of how flexible GraphQL is. And in general, you can see that GraphQL is super flexible. And we've already seen the following examples. So you can have partial errors per field. Also, you can query for exactly what you need. And one example that I haven't discussed yet is that GraphQL is actually transport layer agnostic. What does it mean? It means that GraphQL doesn't have to be on top of HTTP. It can be on top of TCP or on top of some other transport layer protocol that is not HTTP. So it doesn't even have to be on top of HTTP. That's how flexible GraphQL is. Now, I actually had a version of this talk that ended pretty much here. And after that talk, I had people come to me and tell me that GraphQL is so great, so flexible and powerful that they are going to use GraphQL from now on for everything. Because GraphQL is so much better than REST. They even wondered why people ever used REST. And well, this was my reaction. Because the point of this talk is not to make you use GraphQL for everything. The point is to tell you about GraphQL and its advantages so that you will be able to use GraphQL when it suits your use case. But GraphQL also has disadvantages, and it's not always the best choice. So the next part of the talk will be about disadvantages of GraphQL. And the last part will be about some rules of thumb for when to use GraphQL and when to use REST. So my main point for this part is that GraphQL takes a lot of time. And I have three main reasons for that. First, the learning curve. Because to learn GraphQL, I first had to study the specification of GraphQL. And then I had to learn the specific packages that we're using at Salto, which are TypeScript packages, and specifically Apollo Server and Apollo Client. So I had to learn a package for the backend and a package for the client. And since GraphQL is very different from REST, it took quite a lot of time. And I'm still learning new things. Also, because GraphQL is not as popular as REST, so many people already know REST and many have experience with REST, but not so many people know GraphQL. So basically, everyone at the company had to learn all that, both backend developers and front-end developers and even DevOps-oriented people. And even new people that we hire also have to learn GraphQL. So overall, it takes a lot of time from a company to gain that knowledge. The next reason why GraphQL takes a lot of time is its maturity, because GraphQL was initially released to the public about 5 or 6 years ago, and its stable release was only about 2 or 3 years ago. So it's not as mature as REST. And it means that there are less tools, there are less tutorials, and there are less of everything, basically. But the community of GraphQL is very active, and GraphQL is maturing by the day. So you could say that these two reasons are not really inherent to GraphQL, because in like 5 years, GraphQL will be way more mature and way more popular. So these reasons will not be relevant anymore. And well, you might be correct, but I also have a third reason for why GraphQL takes a lot of time, and that reason is inherent to GraphQL. And that is the flexibility of GraphQL. Because as Spider-Man says, with great flexibility comes great responsibility. And let me tell you why Spider-Man says that. So first, let's go back and take a look at a REST request, which is also an HTTP request, of course, and on top of that, REST. So what do we have here? This is a request to GitHub, and we have the method and the status code. So they help me to quickly distinguish between different types of requests and different types of responses. We also have the URL, and because it's REST, then the URL is about the resource that I'm asking for, users, repos, and issues. And then we have the headers, and in this case, there are some cache headers, so they tell the browser that it could cache the request for the response, for 60 seconds. And then, if I'm asking for the same query again, then the browser just returns it from the cache. and it doesn't even ask GitHub for the response. So it's very fast. And there are also some custom headers that GitHub is using about rate limit. So GitHub is telling me that I only have 60 requests and I've already used 8 of them. Now, what does a GraphQL request look like? It looks like this. So basically, the method is always post because GraphQL is transport layer agnostic, so it doesn't care about HTTP. So I can use a post method even for queries and not just for mutations. In addition, the status code is basically always 200, meaning that if I'm asking for a post with ID 1234, and let's say there is no such post, then I will get an error, but the status code will still be 200 OK. Why? First, because again, GraphQL doesn't care about HTTP. And secondly, because there can also be partial errors. So if there is data, is it really an error? Next, the URL. So it's always /GraphQL. It means that I cannot distinguish between different resources based on the URL. And in fact, it won't really make sense to have the resource in the URL because you could ask for multiple resources in one request. And lastly, there are no headers. So there are headers, but they are not part of the GraphQL specification. And I find that in many cases, some headers that are used with HTTP and REST are less useful with GraphQL. And let me show you some examples of the consequences of all this. So let's go back to our Facebook example. And by this time, you've already developed Facebook, and it's very popular, and it's working great, and people are loving it. And then suddenly, some users are complaining that their comments are not loading. Basically, comments are not working for some of the users. And you start investigating, and you find out that there is a bug. So when you ask for comments, sometimes it just throws an error. Anyway, you solve this bug, and you keep thinking about this issue. You're asking yourself, why did I have to learn about it from my users? Why didn't I know about it in advance? And then one of your developers suggests to add alerts on failures. And it really makes sense so that you'll know in advance when such things happen without your users telling you. Now, because you're using REST, this is very easy to set up. All you need to do is log all responses and then set up alerts when the status code is 500 or higher. And probably some people in your company have already done it because it's so common. So it takes you really not a lot of time, because there are also tools that help you with that. Many tools let you log responses and then set up alerts based on the response, based on the status code of the response. And this is important because in GraphQL, the status code would have been 200 OK. So you can set up alerts based on the status code. And actually, if you just want to use the response, then you will have to parse the body and understand it and decide what to do with partial errors. Now, this is an example of how GraphQL takes more time than REST. Anyway, you solve this problem, you set up your alerts, and everything is great again, and suddenly you notice that comments take a lot of time to load. So they're just loading and loading. And again, you start investigating. And this time, this is what you find out. So basically, your database is on fire. It's just working too hard. And you keep investigating to find the reason behind it. And you find out that some malicious users are spamming all of your posts and commenting with ads and links. And that's what making your database work so hard. So now your good users can't see comments anymore. And there are many ways to deal with spammers, but one of your ideas, and the good one, is to add rate limit. And again, because you're using REST, that's very easy. So your goal is to limit each user to not send too many requests. And you define the following policy. You want to limit all post requests to /comments to 10 per minute per user. So each user can only create 10 comments in a minute. And also you want to limit all requests to 300 per minute per user. Now again, because you're using REST and it's very common to have rate limit, then probably some developers in your company have
So hey everyone, I think Ella is having a technical issue. Let's see if she gets in 1 or 2 minutes. In the meantime, what I can suggest, it's a perfect time for you to go out and spread the word about the monthly dev. We are about to start our last talk for today. So open Twitter, share the link to the YouTube talk, add the monthly dev hashtag, and we will pick the 10 most creative shares, and they will win a backpack, a branded daily.dev backpack. So what are you waiting for? Go ahead. This is the perfect time for you to try it out. And yeah, let's see you how good you are in social media. And I think Ella is not going to join back, so let's proceed with the next talk. So I would like to thank Ella, even though she's not here, and yeah, maybe she can send out the slides later on. I will ask her and see how it goes. So for the next and last talk for today, I've been watching his work with Appwrite for so long. He's so passionate about open source, and he is doing a magnificent job. Please welcome Eldad on stage and do lots of noise for him in the comments below. Let's see your love to Eldad. 1 second, you are muted.
Hey, super happy to be here. I'm excited. I've heard from so many people it's the TED for developers, so it's quite an honor.
Yeah, we are very honored to have you here as well. And yeah, the stage is yours, so go ahead.
Okay, great. And super excited to be here today. And our talk today is going to be, just let me set up the slides. So we're going to talk today a lot about simplicity, which has been a private obsession of mine in the last few years. And I'm going to share a bit about Appwrite, the product that I've been working on in the last, I don't know, maybe 15 months, or even a bit more than that. And also about how we tried to make software development a bit more simple using Appwrite, and also to share a lot of the insight that we learned from building a simplicity-driven product and how it affected our internal workflows and how we are trying to achieve that same simplicity also in other areas of our day-to-day lives. So just before I'll start, a quick introduction about myself. So hello guys, I'm Eldad. I'm based in Tel Aviv, and I've been hacking and coding in the open source community for over 20 years now. I'm not that old. I like to believe that I started really young. And formerly, I was the CTO at a company called Walla and a startup called CareerPage. And today, I'm the creator and founder of Appwrite, which is what I'm really passionate about these days. Some things that you need to know about Appwrite. So since 5 months ago, we're not just an open source project, we're also a company, and we're fully remote. We're based in multiple locations around the world, including Israel, India, Germany, Nepal, and Canada. And we always love to add new kind of cool flags into our team page. So we'd love to join any one of you. All of our team members started as contributors of our open source project. If I haven't mentioned before, Appwrite is completely open source, and you can go over to GitHub, to our GitHub repository or our website and check it out. And to really understand what Appwrite is trying to do, now is trying to make developers' life simpler, it's easiest for me to start by mentioning some of the problems that we were trying to solve. And I was basically, when I started Appwrite 15 months ago, it started just as a side project, and I was trying to basically solve my own problems. I wasn't too nice. I was really focused on myself, and I tried to solve problems that if I would be required to find one title to those problems, so it would probably be that software development has become really hard, and it's like becoming harder, like as we move on. Like new complexity keeps on piling up for software developers. And it's really hard these days to be a software developer. And I can probably mention 1,000 reasons why software development is so difficult. But for me personally, I like to really focus on 3 main issues that I felt like was the main issues that caused me to start developing Appwrite as a side project in my spare time. And the first one is probably that in order to be a developer today, you have to know so many things, like from different frameworks to different theoretical concepts, like design pattern, object-oriented programming. And you've got so many frameworks you have to learn. If you're a front-end developer, there's probably a new framework every 2 weeks. And I used to say, like, software development isn't really rocket science. But honestly, I don't think I feel that comfortable saying that today, because there are just so many things to know. The other issue that really burned in my bones was that I've seen, and that's something that I've really seen a lot as someone who needed to manage multiple development teams. When I was a CTO at one of my previous companies, I had to manage like 4 different R&D teams, over almost 30 engineers. And I've seen so much repetitiveness. And as a tech leader, that really bothers you, because you want to create innovation, you want to give value to your products that you're developing. And I've seen so much waste across different development teams. And it's like, it's really hard for us as developers to find common abstraction points, especially when we don't see the bigger picture. And this repetitiveness don't happen only on a specific team. It can happen like between 2 developers that are just sitting a chair to each other. And it definitely happens when you move between different organizations. And for me, when I started working on my first startup, where I was the co-founder and CTO, I really felt like the entire process of building the company and the product was super repetitive. I felt like 70% of the job that I'm doing is just solving old problems and stuff that I basically already solved before. And beside the fact that that's really not effective, and as a founder of a startup, you really want to be focused on innovation, creating value for your end users. It's really boring to solve all problems again. And I was feeling like I was writing the same code, I was writing the same algorithm, the same services, the same APIs, the same libraries. And yeah, it was so frustrating. And I've started by saying developers need to know so many things, and probably software security is one of the biggest things developers have to know today. And for me as a CTO, that was the one thing that kept me up at night, like the thought that one single developer in my team can create a bridge with a single line of code that can compromise the entire organization. It was horrifying for me. And like looking at all of these problems, I really spent so much time like trying to realize, what are we doing wrong? Why is it so complex? Why is it so hard? Like I like to view developers as like modern artists. We shouldn't be dealing so much with the technical parts, dealing all the time with how to manage and solve, and sometimes even reduce complexity if we're really into that. And I came into the conclusion that most of these issues can come under one category, and this category is probably complexity. And when I was thinking about it, I felt like complexity isn't really unique to software development. You can probably see it in every industry out there, right? You can see probably most startups out there are trying to solve complexity in some way or another. And usually what you try to do when you're trying to solve complexity is use abstraction. And we use abstraction in our code all the time. Like that's one of the most common stuff that we do in our daily job as developers. And when you use abstraction, you try to hide a lot of complexity behind a much nicer interface, and you want to make that interface accessible for your end users to allow them to basically create the same amount of job with better quality and in much faster times. And when you talk about developers, so my view of that was that those interfaces should be APIs, because APIs are like probably one of the best abstraction points that you can still give developers a lot of freedom, but hide a lot of complexity behind it. So that's exactly what we're trying to do with Appwrite, basically. We're trying to hide a lot of this complexity behind an end-to-end platform. So what Appwrite is basically it's a self-hosted solution that is packaged as a set of Docker containers in a microservice architecture that you can easily install on any kind of infrastructure. Whether you're using AWS, GCP, Azure, even your own local computer, or from Appwrite next version, even a Raspberry Pi 4. And once you set up Appwrite, and the installation process takes 2.5 minutes probably, just copy pasting one command line in your terminal, assuming you have Docker CLI installed, you get all those tools and APIs that you would usually need either to build from scratch, use different open source libraries to try and combine them into working services, or even sometimes like trying to combine different third-party services that are dedicated to specific solutions and try to make them work together in order to combine a product. And once you set up Appwrite, you get all those APIs, and all those APIs are being accessible to you using APIs and tools and existing knowledge that you already possess. So one of the main goals of Appwrite is that, or philosophies of Appwrite, is that you can't solve complexity or reduce complexity by introducing new sets of complexities. So Appwrite is this end-to-end unified solution. You can call it a backend as a service if you'd like, but I don't really like to use that term because I don't think Appwrite is trying to replace existing backend solutions as like the classic backend as a service, but rather Appwrite is trying to give you much better starting point to your projects with all those tools that you would usually need. So between the different services that Appwrite offers today is an authentication API, a user management API, a database that can abstract all the persistency needs that you need in your app if you need to save users' data or your application data, and even segment it, like say a specific document can be accessed only by a set of users or by a team of users. So you can do it really easily, and same for the storage API and even cloud functions and other more advanced capabilities like real-time that basically will allow you to create any kind of use case and application using this stack. Just to give a bit more understanding of how Appwrite works. So Appwrite is completely agnostic to your end platform. Because we're operating in the API layer and we're not building any widget or we're not interfering in any UI, we just build APIs and we build them for developers. So Appwrite can connect to any kind of end platform, whether you're using web, mobile, Flutter, or even an existing backend. Like Appwrite can even work entirely behind your organization firewall. You don't need to expose it to your clients. And it can work really well with existing backend. Like let's say you have a really good Elasticsearch server that you're using for search. You don't have to replace it. Like you can still use the Appwrite authentication service and combine between them using cloud functions, webhooks, or even the backend API as some of our backend SDKs. So we really have to treat Appwrite as or backend and clients as equal citizens in the ecosystem of Appwrite. And Appwrite has today a single entry point, a single API entry point, and this entry point is currently a REST API. But we're not limited to it. Only to that. Actually, in the next few versions of Appwrite, we're going to release also GraphQL, real-time using WebSockets, and other protocols to really leverage existing developers' knowledge. Because again, you don't want to solve complexity by introducing new complexity. And sometimes a new complexity can just be like a new protocol that the team doesn't know how to use. So yeah, some teams really like REST APIs, and they find it really difficult to migrate into GraphQL. And some teams would prefer GraphQL just because they already feel comfortable with that. So in terms of our product philosophy, I think we're really opinionated at how we build the product, how we design it, and how we create this great developer experience that makes everything so simple for developers. But on the other hand, we are really, really unopinionated at how developers should consume Appwrite and how they use it, from their end platform to the protocol that they want to use, or to the different setup or services that they would like to consume. Behind the different entry points, we have this really fixed security layer that aims to take care of a lot of the stuff developers need to take care of and don't really have a lot of time in all companies or in all products to really accomplish. So basic stuff from input validation to abuse control and rate limiting to auto-generation of SSL certificates, custom domains, and many more features like virus scanning to compression and hashing of your data. And actually, there are so many security features that I probably can't list them by heart anymore. But you should check out our docs and learn more about them. Behind our security layer, you can basically see all the different Appwrite services. And what's really cool about those services is that we don't really build them from scratch. Like, Appwrite doesn't build its own database service under the hood. We actually leverage existing open source technologies that are already bullet-proven, and most importantly, that developer teams feel comfortable at consuming. So you can see on the right that basically this is all the complexity that Appwrite is trying to hide. And maybe I don't like the word hide, because I think developers should be completely aware of how things work under the hood, but at least they don't have to care about them as much. So for the database, for example, we're using MariaDB as a storage engine. And in the future, we're going to create different adapters, like if a team prefers to use MongoDB, for example, or Postgres, that's just fine. And you can replace them easily. And you can even use like managed solutions like from AWS or GCP, just to make sure that you feel comfortable with how your setup is working. Another way to look at Appwrite is like cloud providers have been great. Like they have been the best abstraction layer on top of physical data centers. And trust me, managing a physical data center is really not a fun thing to do. But cloud providers, cloud vendors are not designed for developers, right? Like, it's a completely different domain, a different language, different target audience. Like, the target audience is probably DevOps and XIT guys. It's not for developers. And I think Appwrite is a really a nice way to look at Appwrite as an abstraction layer on top of cloud, taking all the cloud capabilities and translating them into APIs that developers love to consume. So a lot of what we're trying to do is basically build this really nice developer experience. Like a traditional company would spend so much time and money at building great user experience, we're trying to build really great developer experience with our APIs, our naming convention, and even how our docs are looking. So as I mentioned before, Appwrite is completely language agnostic. You can probably use any platform that you already use. And we have 8 official SDKs, and we're rapidly adding new ones all the time. And we'd love to get more contributions from our open source community. If someone wants to contribute a new SDK for a specific platform, the process is really easy. And a lot of the SDKs that we have today have been contributed by our open source community. Appwrite is growing really, really fast. It actually has been a bit overwhelming. We have released the open source project initially like 15 months ago. And since then, we've been one of the fastest growing GitHub projects in terms of stars, with almost 7,000 stars, growing rapidly in the last couple of weeks. We've got a really vibrant community over Discord of almost 2,000 developers. And the product has over almost 1 million Docker pulls. The product is completely based on Docker. And that has been really amazing and astonishing for us. We've got over 220 open source contributors from almost 50 countries, which is probably one of the metrics that we're most proud about. And we're always seekingly looking for new contributors to join our community. And if you want to join, you can just go out to our repository, read the contribution guide. That's the same contribution guide that new team members that join Appwrite go through when they first start working with us. So it should be really simple, and we're always striving to improve it. And I'll talk a bit more about that as we move on. And if you're already in the Appwrite community, you should be excited, because we're almost releasing version 0.8. It's just almost there, and I promise it will be sooner rather than later. And you can check out all the new features that you can expect on our Dev2 blog. So that's nice. Like, we've built a really simple product that developers love to use, and hopefully we're able to reduce a lot of the pains and allow developers to be more innovative, rather technical. But that wasn't enough for us. And while working on Appwrite, we kind of got the feeling, okay, it's one thing to build a product and make it simple, but it's another completely different thing to scale as a team and make sure that we, both as a team and as a community, and make sure that the same product philosophy stay intact and being preserved, and we're still and we are still able to continue to produce the same amount of quality in the APIs and tools that we build for developers. We started to think about how can we take that simplicity approach that we apply on our product and take it to other parts of our company. Basically, if you're in our Discord community, you can hear a lot the saying that we should eat our own dog food, we should use our own tool, we should embrace our own philosophies. And as we move along as a team, we really try to see what are the key things that we can do in order to preserve that culture and strive towards this concept of simplicity-driven development. The first thing that we've done, both as a team and a community, is to invest a lot more time into our design process and basically have a process that forces us to build features and design them before we actually build them. Because, as I mentioned before, I truly believe that developers are like modern artists. And I think the coding part, as much as we love it, we're all developers, so we love to code. It's not the most important part. It's kind of the technical part. And for us, the creation part, the more creative work is being done actually at designing a feature. So we started for Appwrite, we started an RFC repository where we are able to build this manifest for a new feature. And most importantly, we also have the ability and opportunity to get our team feedback. And luckily for us, because we're an open source project, we can also share our RFCs with the community and get a lot more feedback. And this gave us like this superpower where we have like a community of consisted of thousands of developers that always pushes our product into the right direction. We feel like almost we can't make a mistake, because when we do make it, someone will raise a hand and we'll be forced to fix it really quickly. So that has been working really, really great for us. And it allowed us to really put a lot of effort on how we combine different libraries and different APIs into a working product, rather than just tackling the code and trying to achieve features and releases, but also make sure that we create a lot of value and quality inside of the process. The other thing was, in order to try and avoid complexity as much as possible, we really wanted to make sure that we split every component inside Appwrite into the smallest, simplest piece of software that we can do. So on the top layer, we view Appwrite as Appwrite the product. But Appwrite the product is actually consisted of multiple microservices, where each microservice has only one and single responsibility. This responsibility can be like as simple as possible. It can be a bit more complex, but it has to be one, and it has to be really, really obvious. Beneath that, we have like multiple code repositories and packages that actually combine those services together. This allowed us to better reuse some of our code, but also make sure that each piece of code is really focused on a specific goal. Like, for example, we can take like our storage library, which only handles like file manipulation, compression of files, and uploading files into different services. On the other hand, we have our database library, which only handles like an abstraction on top of existing database adapters. And using that method, it's really easy for us to maintain the code, but also decouple responsibilities and make sure that each piece is completely replaceable. We can refactor our code easily. And our documentation is super organized because we have all these small pieces, which each one of them like have a README, have its own API spec, and makes things a lot cleaner for us. Another thing that was really important for us to understand is that we can't decouple our architecture from our team structure. So this came into practice when we chose, like, are we going to work with a monolithic repository? Are we going to work like with multiple packages? What services should be like their own services? What should be part of the main proxy or other stuff? And a big team like that's build a specific part of your code. That part of the code should be its own package. Maybe it should be its own service. Like, architecture should match your team structure and your team scale. And if you're planning to scale as a team, you might want to make sure that the architecture that you have also reflects that. And I think we've done it a lot of times. And it's also an evolving process because the team can grow, the team can shrink, and you need to adjust and make sure that your team is able to maintain that kind of architecture in a way that it's easy and reasonable. Okay, the next thing that we had in mind is that we need to write code for humans. And a computer would understand your code, but you should understand like that maintenance would probably take a lot more time as you move on than building new features. And in order to maintain the code in a reasonable way, it should be very, very clean and organized and written for human. So at Appwrite, we spend a lot of time like in naming conventions, understanding what is the different scope and domains of different stuff. And also other stuff, like understanding that the shorter way is not always the better way. Our code should tell a story. It should be understandable by others. Sometimes it's better to copy-paste. We have this famous example of the left pod repository, which contained like 3 lines of code and like half of the universe used it. Sometimes it's just better to copy-paste if it makes the code more reasonable. And yeah, and trying to add functions everywhere is sometimes it's just lazy, and trying to reuse every line of code is just not possible. Just make sure that your code is simple, and you have to find the right balance between reusability, performance, and maintenance. And sometimes like we would give up performance like if it's not really meaningful in order to make sure that the code is easier to maintain.
So Eldad, sorry to interrupt, but we are running out of time. So if you can wrap up and we can go to the questions because we have a few of them.
Yeah, sure. I'm just wrapping up. Yeah. I've got like two more slides. So one of the last thing we had is we need to document everything. And we shouldn't write documentation only to how our product is working. We should also create documentation for maintainers that are going to join in our team or join from the open source community. And we have over 200 contributors. So it's really important that they will have an easy onboarding process. From documenting everything to the function level, to the repository level, to the service level, to the end level of how to use the product. That was really important for us. And also to treat documentation as first-class citizens. It shouldn't be an afterthought. Like when we plan a feature in Appwrite, we like try to understand, okay, what kind of docs do we need to create? Do we need to create some example? Do we need to create some tutorials? And all of that is part of our scope. So we're trying very hard to not treat documentation as something that we'll have to think later. And it's really shows in our architecture and the way that we build, how we treat docs as a native part of the code building process. Most importantly, every company, every developer should find his own path. We're still learning and we're still trying to figure out how to reduce complexity. What I've showed today is just some of the tips that we had, that we learned that helps us. But we'll keep evolving, we'll keep testing ourselves, and we'll keep on thinking, how can we do better? And that would be my best advice to all of you. Thank you, and feel free to follow us on Twitter, give us a star on GitHub, and test out Appwrite. And we'd love to see you on our Discord community, where we are available and you can chat with us.
Thank you very much, Eldad. Actually, a few people here mentioned that they already started your repository on GitHub. So I highly encourage everyone to go ahead and do it now, so you won't forget. And we have a few questions from the audience, so let's start. So how does Appwrite compare to something like Supabase?
Well, Appwrite and Supabase are similar in a lot of ways. I think both products has a different set of features and a different philosophy on how to build a product and a different approach to how to do open source. So I think you should check out both and see which one you like better. And hopefully it's Appwrite.
Is Appwrite production ready?
Yeah, so we're currently at version 0.7. We're just about to release 0.8, and we're running really fast towards 1.0. Appwrite is still not officially stable, but we have seen a lot of production use cases. You can feel pretty comfortable, and we're giving backwards compatibility even when we're still not at 1.0. But yeah, not officially yet.
Perfect. Another question is using an open source backend is a security issue of some sorts?
Well, I think this question actually is not very specific to Appwrite. It's a bigger question about is open source secure to use? And I think most companies out there, probably 90% of the technology today is on open source. I think there are a lot of advantages and some disadvantages to using open source, but at the end of the day, when you have a big community like ours that is working on the same product and everyone has a lot of stake into it, it just makes the product better. And I've been working in a lot of enterprises, and open source code is probably in a much higher quality. Like, you're showing yourself out there, so you're giving a lot more effort. And yeah, I think open source products are a lot safer to use.
Yeah, I agree, because also there are more eyes on the code that can search for issues and fix them.
Definitely, thousands of eyes. Like, we still find it hard to believe sometimes how many people view the code and give us comments and send pull requests out of nowhere.
Yeah. So that's it. There are a few more questions. If you can hop on the YouTube video and search them and answer them on the comments, this will be great. Sorry for the rest of you who asked questions and we didn't have the time. So thank you very much, Eldad, for coming here. Thank you for doing such a great work for the open source community.
Thank you. It's been my pleasure. And maybe I'll be here again sometime.
Yeah. It will be great to host you again. Thank you very much. Enjoy the rest of the day.
Thank you, guys. It's been a pleasure.
Bye-bye. So Ella is back with us. She has a few more slides that she would like to share with you, so she can finish the GraphQL talk. So I hope you're ready. Ella, you are back in. Good luck. Let's do it quick.
Thank you. Sorry, I just lost the internet connection. Anyway, so some users are spamming your site with many comments, and you want to add rate limiting. So with REST, it's very easy because you have tools to help you, and you can just set up these rules in your managed API gateway, for example, based on the method and the URL, and that's it. And based on the user, and you can just have the managed service take care of rate limit for you. Now, if you're using GraphQL, then you can distinguish between different types of requests based on the method, because both creating comments and reading comments can use the post method. And also, the URL is always /GraphQL, so you can't use that either. So in fact, your managed service will have to parse all the incoming requests and have its rules based on that, because that's the only way to distinguish between a request that is creating a comment or a request that is doing something else. And parsing the body of all incoming requests is slow. And on top of that, some users can actually craft these very big requests, like a request that is asking for all of the posts and all of the comments and all of the members and all of their friends in one request. So limiting by the number of requests is not enough. You actually have to give a cost to each request. And there are tools to help you with that, but it's not as straightforward and as easy as with REST. So as you can see, the flexibility of GraphQL can really take you more time to handle. Now, as you can see, GraphQL solves many of the problems as we've discussed. It helps you avoid breaking your API. It solves overfetching and underfetching. It helps you reduce bandwidth usage. And it forces you to use a schema, which has many benefits. But GraphQL also takes a lot of time because of the maturity of GraphQL, because of the learning curve, and because of its flexibility. So how can you choose between REST and GraphQL? Well, I think that in many cases, any of them is good enough, because both GraphQL and REST are really good choices at the end. And also, in some cases, you might want to use both. You can have, for example, an architecture where you have many microservices with a REST API, And then you can have a GraphQL layer on top of that to serve as a glue between them. Or you can have an architecture where some of your microservices, you have many microservices, and some use REST and some use GraphQL, depending on the use case. Anyway, when you have a specific service and you want to choose between REST and GraphQL, then in my opinion, REST should be the default choice, because REST is more mature, it's more popular, there are many more tools for REST, and it just works great, and it has worked great for many years. So if you don't have a good enough reason to use GraphQL, then you should simply stick with the good old REST. But there are cases where GraphQL will be the better choice. And I think it mostly depends on two factors, your clients, and your data. And let me elaborate on that. So I have this cheat sheet, those rules of thumb for when to use GraphQL. First, think about your clients. Ask yourself, how different are your clients? Basically, how different are the requests that they're going to make? So if the requests are very different, then the flexibility of GraphQL can really help you. And also, even if you only have one client, for example, only a website, then if you have many front-end developers and many front-end features, then your front-end is changing very fast, and it can count as though you have many clients in a short period of time. So that also counts as though you have many clients, and in this case, GraphQL can also help you because you won't have to change your backend for every little front-end change. In addition, ask yourself, do you have bandwidth-conscious clients? So basically, are you supporting mobile phones? Because GraphQL can help you reduce bandwidth. Next, your data. So your API is probably serving data. And ask yourself, how many different resources do you have? How many fields each resource has? And how well connected are your resources? So if you have many resources with many fields each, and they're very well connected, creating this big graph, then the flexibility of GraphQL can really help you because you can choose which fields to ask for and which relations to follow. For example, in one request, you could ask for some posts and then their comments, and then the author of these comments, and then the friends of these authors and their names. So it's super flexible. But if you are, for example, creating a simple blog, and all you have is two resources, post and comment, and they have like 3 fields each. So the flexibility of GraphQL won't really help you because you can simply return all of the fields, and it won't really matter because all you have is 3 fields. So you see, it really depends on the use case. Now, to sum up, as we've seen, GraphQL has many advantages, but it also has disadvantages, and it really depends on your use case. So the next time you are designing an API, I hope you really think about your own use case and choose the tool that suits you best. Thank you.
Thank you very much, Ella. It was a great talk. Actually, we use GraphQL as well, and I simply love it. And yeah, as you mentioned, you need to choose your tools for each problem.
Yeah.
So
totally.
the audience was all about it. They showed their love and everything. So thank you very much. Thank you for coming.
Thank you. Thank you for having me.
Bye-bye. So we are about to close another event, and I'm sure you can't wait already to hear who won the raffle of the month. So let's see how excited you are in the comments. So share a clock emoji, a watch emoji, because we are sharing a new Apple Watch today. So let's see who won the raffle. Our winner for today is Tomer Bar. Please, Tomer, if you are here, we would like to let you know that you won a brand new Series 6 Apple Watch device. We will reach out to you with all the details, so keep your eyes on the mailbox. We will make sure to follow up there. If you want to also win an epic prize, just like Tomer, all you have to do is invite your friends to use daily.dev. And would you like to see what prize we are offering this time? We are giving away a Razer keyboard, the Black Widow version 3, And all you have to do is invite your friends to daily.dev. All the information can be found in daily.dev/monthly-prize, and you will get on all the instructions there. We will make sure to announce the winner on the next event on the monthly dev 5 on May, at the end of May. So that's it, folks. I would like to thank you all for joining, and I would like to welcome you all to join and RSVP to our next event on May. We have such a crazy lineup that also includes Quincy, the founder of Free Code Camp. So make sure to join us. And if you missed our previous events, you can check all of them on our YouTube channels, and make sure to also subscribe so you don't miss any events. So until then, see you next time. Bye-bye.